5, 4, 3, engine start. 1, 0, and liftoff of the Delta rocket carrying GLAST, a gamma-ray telescope searching for unseen physics in the stars of the galaxies.
Launched on June 11, 2008, GLAST, renamed the FERMI Gamma-Ray Space Telescope, has been collecting gamma-ray data for 5 years. In that time, it has made some astounding observations of some of the most powerful events and objects in the universe, including some right on our doorstep.
FERMI looks at gamma rays, the highest energy form of light, and it just surprised everyone with a discovery about the fabric of space and time.
Because FERMI saw no delay in the arrival time of the two photons, it confirms that space and time is smooth and continuous, as Einstein had predicted.
With FERMI, astronomers have made the most accurate measurement of starlight in the universe and used it to establish the total amount of light from all the stars that have ever shone.
In April 2013, a shockingly bright blast of gamma rays from a dying star in a distant galaxy produced the highest energy light ever detected from such an event.
Every 3 hours, the Large Area Telescope on board FERMI builds up a picture of the sky in gamma rays. One thing it sees a lot of is blazars, active galaxies whose emissions are powered by supermassive black holes. Because we're watching them all the time, we can track their activity and alert other telescopes to new flare-ups.
2 years of scanning the sky with FERMI's Large Area Telescope have set the strongest limits yet for WIMP dark matter. The longer FERMI operates, the better its ability either to box in the nature of dark matter or to find actual evidence of what it is.
Scientists have recently discovered a gigantic, mysterious structure in our galaxy. This never-before-seen feature looks like a pair of bubbles extending above and below our galaxy's center.
New images show where supernova remnants emit gamma rays 1 billion times more energetic than visible light. This glow suggests that the remnants are a source of cosmic rays, protons and electrons accelerated to near light speed.
Observations of 2 supernova remnants by NASA's FERMI Gamma-Ray Space Telescope conclusively show these supernova remnants are accelerating protons. When they strike protons in nearby molecular clouds, they produce the gamma-ray emission FERMI sees. Recently, astronomers have observed incredible flares in the nebula that theorists are hard-pressed to explain. The gamma rays most likely arise from electrons moving near the speed of light. But to account for these flares, the electrons must have the highest energies ever seen in cosmic sources. In 3 years, FERMI has detected more than 100 gamma-ray pulsars, and about a third of gamma-ray pulsars were discovered by FERMI on the basis of their gamma-ray pulsations alone. In late 2010, NASA's FERMI Gamma-Ray Space Telescope watched the system glow with faint gamma emission as the pulsar first approached the disk. Astronomers expected the same behavior in early 2011 when the outbound pulsar grazed the disk again, but instead, FERMI detected intense and puzzling gamma-ray flares.
We managed to get enough observations of the object to piece together its orbital period and found, remarkably, that it was an incredibly heated object, blue-white on one side, deep red on the other, that was orbiting around an energetic pulsar with an orbital period about 1.5 hours. The gamma rays are blasting the companion at point-blank range.
FERMI found that star birth and death in the Cygnus X star factory corrals particles and boosts them to cosmic ray energies.
In early March 2012, a powerful flare erupted on the Sun. During this event, the LAT detected the highest energy light ever recorded from a solar flare.
New observations by NASA's FERMI Gamma-Ray Space Telescope show that thunderstorms make antimatter. The process starts with a terrestrial gamma-ray flash, or TGF, an intense pulse of gamma rays originating from thunderstorms.
Scientists have discovered that radio signals, once thought to be produced by the lightning that triggers a TGF, are in fact broadcast by TGFs themselves.
There was a defunct Russian satellite in an orbit that would intersect FERMI's orbit in about a week.
Those two spacecraft were occupying the same space within 30 milliseconds of each other. That's why this was scary. Having done the maneuver and avoided a collision means we continue operating. So continue doing the great science that we have been doing over the past 4.5 years.